In a lot of counting methods questions, there's a lot of patterns that end up happening, and we end up being able to use a very special notation called factorial. This happens in a lot of questions that I would call arrangements. Something kind of special happens during arrangements. Let's say I have 5 people. They are in a line, and we can move these people around. And anytime I have, say, an arrangement like A, B, C, D, E, and maybe I move these 2 people around, and now it's B, A, C, D, E, I could say that is definitely unique. And this is a new arrangement, and it would totally count. Let's say they're in a line and I'm taking a photograph, and there's some meaning behind this, and every little variation matters, and I definitely can't repeat the same thing twice. Once one person has been selected, I can't put that person in again. And so what ends up happening in a lot of these calculations is that we start seeing a countdown of options. And we got to start somewhere. And in this case here, there's 5 options. There's 5 people who could be first. There's no restriction in per se. And in the counting principle, the fundamental counting principle, which always analyzes how many options there are, how many different things, how many different people are allowed to be in that spot. I mean, it could be anybody. There's 5 people, so there's 5 choices. But once somebody has been arranged, if this person was picked, they could no longer be picked again. They would not be an acceptable option. B is now gone out of this selection list, and we get this natural countdown. And then we have one less. And then we have one less, and then we have one less, and then we have one less, because of this natural way of selecting real things where you don't really have the same item twice, like a person. Once A is selected, A is not to be selected again. And then you're down 2 options, and now there's only 3 good options. And you can kind of see there's no matter what was picked, there is going to be this countdown. And these countdowns happen so often where, from during this progression, you're going to lose one option every single time you kind of move to the next step, and you get these full countdowns. Now, this can be summarized with a counting methods, a permutation combination symbol called the factorial. 5 factorial is condensed. It's a way of saying this whole statement in one just little notation. And it assumes that the countdown was complete. All 5 people were being arranged. And it's literally kind of when I read these, when I see these in answer keys, when I want to use them, to me, this means that we were arranging, 5 things, 5 people, 5 books, 5 letters, 5 numbers, whatever the context might be. And we can create this symbol. And it's I and then and I honestly I urge caution using this symbol, because not every single question includes this pattern where you have to lose one option. There could be partial countdowns. There could be a break in the countdown. There are many different situations that happen, but once you can see the full countdown, that's when I would say this symbol becomes a little bit more elegant in a way. It just so fancy and proper that we like to use it. Now, what happens when we start cutting these countdowns off? So if I created a different situation, let's say that there are 10 people, but only 3 are lining up for a photograph. And in this case, once we start selecting people, and I mean, I am selecting from all 10 people, I am taking these 10 people, and because I am lining them up for a photograph, I would also kind of throw out there that this is precisely the kind of question that I could call an arrangement. And as I select people, let's say I've got all these different people. Let me just pretend these are people. H I and J. One more. There's 10 people. There's all these 10 options, and I'm only picking three. There's 10 options. And so once I start selecting three, for example, maybe these three people are selected. That's one way to line up three people from all of those options. And it does count as an arrangement because the second I just start moving these people around, it's totally new. That's not a duplicate. That is a completely different way to create a photograph. It might be the same people, but putting someone else in the middle, putting different people out on the end, that is a little bit of a different photograph. So it does count under kind of our rules of don't count duplicates. So when we pull up the fundamental counting principle, it would kind of, how many people would be allowed to be first, or how many people are available to choose from to pick first. And there's a lot of options. There's 10 people. I don't have to just pick, this person. There's not one option. There's not three options. There's 10 options. And then there's nine, and then there's eight. Once people are slowly selected, once one person has been selected, you can't pick that person again. You're down to nine. And then once a second person is selected, you're down to eight. But then the photograph is full. The countdown doesn't keep going because we're not selecting people anymore. We got to back that up, and we just boom, we're done. And it was like the countdown was proceeding, but it kind of got cut off. So we have to kind of come up with some symbols for this, or at least it would be nice to understand the symbols that go for this. Now, 10 factorial just won't do. 10 factorial is assuming that the countdown did go down forever. 10 factorial is 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1. It's a huge number. In fact, if I was just to type in 10 factorial, it's going to give me a really big answer, like 3,628,800, which is way bigger than what this broken countdown gives me. 10 times 9 times 8 is actually just over only 720 different photographs. So this just won't do. So one thing that we can do is we can create or cancel the countdown that does not exist. And so this is kind of saying that, hey, we're arranging 10 people, which in theory we were at the very start. But how many people did not get picked? When I take it away, when I divide out and cancel out the countdown, there were 7 people not being arranged. They just didn't make the photograph. And when we divide by 7 factorial, we can kind of take out that countdown that never existed. And so if you type that in, I promise you're going to get 720. And there's even more appropriate symbol, because this whole fraction business it's starting to get a little bit messy. It's not even convenient anymore to kind of write this. And so they've invented this notation called permutation. Permutation, to me, is the exact same word as when you're doing arranging. When you're doing an arrangement, when any sort of movement of people is totally changing the situation, it's changing the photo, it's changing the race, whatever the permutation might be. Now, in this notation, they use little numbers, and this would be the comparable thing, 10p3. It's This is what we would call the n value of the permutation. It represents all the options, the total number of options. And this is what we would call the R of the permutation, which to me is exactly how many people, this one's about people. So how many people are being arranged, not how many people are not making it, because we're not dividing in this in 10p3 specifically, but how many people are being arranged. And between these symbols, it kind of opens up a couple options. The counting principle is, to me, is totally fine. This is what I do. As hard as the question might get, I'm still going to just show the options. I'm going to show the countdown. I'm going to stop the countdown if necessary, and I'm just going to write it. And it's just whole numbers. I don't mix factorials into this notation whatsoever. Factorials is a nice way to make a countdown look nicer, although these fractions to me are not even that convenient. So I would be a little bit hesitant even to use this notation, although it does give us the same answer. But there are situations where this permutation notation is a lot quicker maybe than writing 10 times 9 times 8, because your calculator has these buttons built in. But again, you have to use these carefully. 10p3 is a very, very specific calculation in a specific situation where the countdown has been cut off, where it's an arrangement question. It doesn't work for every question this unit. There is very special times when you might want to use this. So hopefully this has kind of opened up the doors to some different notation that we can use in a lot of these problems.